So we are going to talk about two special triangles. Special triangles. The first one we're going to do is if I have sides of 1 and 1 on a right triangle. So I'm going to generalize this and we're going to come up with a relationship based on if I have legs of 1 and 1 for a right triangle. So if these two sides are the same, we know this is 90 degrees, then we can assume that the angles across from them need to be the same if the sides are the same. So the angles would have to be 45 and 45. So, because if those two remaining angles should be 90, cut that in half. Now I could figure out the last missing part, the hypotenuse, using Pythagorean theorem. A squared 1 squared plus b squared 1 squared equals c squared. So this is going to be 1 plus 1, which is 2. Take the square root. So the hypotenuse is the square root of 2, which typically we would actually calculate what that is as a decimal. But for these purposes, I'm going to leave it square root of 2 right now. So this would be a relationship, let's say a foot, square root 2 feet, which is actually about 1.4. But I'm going to generalize this. So now I'm going to generalize this that the hypotenuse is going to always be x root 2 if the legs are x. So whatever the legs are, x, the hypotenuse is always going to be x root 2. So here's an example where I can use this. Let's say we've got, I know that the legs of a right triangle are 5.8 centimeters. Find the hypotenuse. Hypotenuse. So I can sketch this out. That means I've got 5.8 and 5.8. I could use the Pythagorean theorem, but now with this shortcut to get that hypotenuse, all I have to do is 5.8 times the square root of 2. In most calculators, if you put it in 5.8 square root 2, right away it'll calculate the answer even without putting multiply, and we get 8.2 centimeters. Okay, so that is this is called a 45, 45, 90 sometimes as a special triangle. Also on this example, let's say if I were to be asked what's the degrees, I know that these are 45 degrees each. Since the legs are the same, that means the angles have to be 45 degrees. Okay, the other special triangle, we're going to start this one off based on what if I have an equilateral triangle all with sides of 2. So if I have an equilateral triangle, all the sides the same, then that means my angles would have to be 60, 60, and 60. 60, 60, 60. Since we have 180 degrees in any triangle, divide that into 3 equal parts, and I get 60 that way. So right now there's no right triangle. Pretty much right now I have all the sides and all the angles. But if I cut this in half and drop this down to make a 90 degree, then that means now I have 30 degrees right here. So I'm going to redraw that just half, a little bigger. So if here's my 90, 30, and 60. The other things I know right now, the hypotenuse is 2. The base down in the bottom, if I drop that line straight down, I cut 2 in half, so this is 1. So the last thing I don't know right now is the vertical side. So if I do the Pythagorean theorem, a squared 1 squared plus b squared, I don't know, equals 2 squared. So 1 plus b squared equals 4. Subtract 1. b squared equals 3, so b equals the square root of 3. So this one as well, I can generalize this. If we think about what's the best one to call x here, well, the one that's 1, we'll call that x. So the hypotenuse is always double that, 2x. And the vertical side, the one across from 60, is always x root 3. So this is called a 30, 60, 90 triangle. So let's do an example of using this. So let's say I want to find the missing sides of this triangle I'm going to draw. So if I draw out a triangle, let's see, let's do a little better than that. So I'm going to put 30 on top, 5 is the vertical, 5 feet, and then I've got 90 degree right here. Okay, so I'm going to fill in, I know 60 degrees down below. I'm going to put my labels of my generalizing down. So across from 30 is always x. So across from 30 is x, hypotenuse is 2x, and across from 60 degrees is x root 3. So in this one, I don't necessarily know what x is yet. I know that the x root 3 side is equal to 5. So I need to divide both sides by square root of 3 to get x now. Okay, so if I do 5 divided by square root of 3, I get 2.89. Okay, so that means the side down below, 2.89 feet. And then to get the hypotenuse, if I double that, I'm going to get 5.77. So if we kind of look around, 5.77 feet, 5 feet, 2.89, 5.77, that seems reasonable for the three sides of that right triangle.